Hi everyone, my name is Daniel and I want to introduce you to the work on the topic algorithm for fixing singular defects of polygon meshes based on half-page data structure for the third international workshop on computer modeling and intelligent systems. So let's start. More recently, 3D printing has been viewed as something completely new. The technology was underdeveloped, the hardware was too expensive for widespread use, but only a few years have passed and the situation has been changed radically. 3D printing is one form of additive manufacturing technology where a three-dimensional object is created by imposing sequential layers on material, printing, growing according to the digital model. Digital 3D models are a key component in a large number of industrial and scientific sectors, such as product development and production, gaming and simulation, archaeology, medicine, and others. A polygon mesh is a collection of vertices, edges, and faces that defines the shape of polyhedral object in 3D computer graphics and solid modeling. The faces usually consist of triangles, quads, or other simple convex polygons. Since this simplifies rendering, but might also be more generally composed of convecting polygons or even polygons with holes. Polygon meshes may be represented in a variety of ways using different methods to store vertex, edge, and face data. These include face-based data structure as a simple list of vertices and a set of polygons that points to the vertices it uses. Edge-based data structure in which each edge points to two vertices, two faces, and four edges that touch them. Half-edge-based data structure is similar to edge-based meshes, except that only half the edge traversal information is used. This approach, unlike the other, provides tremendous opportunities to bypass the topology. Polygonal mesh is laced with such types of defects as geometric and topological. The essence of the first lies in the calculation error at the stage of modeling the model. Topological defects have a somewhat different source of occurrence. However, the result of the presence of such defects will be inability to recreate the model in the real world. I would like to pay special attention to topological defects, namely singular ones. Singular defects can occur in many cases as a result of the operation of many missing vertices. This may also be problems of translation of geometry from BREP. Converting format from PLI to STL can also damage the topology because the PLI format supports polygons of various shapes, but STL only triangles. I would also like to note that topology validation can be obtained during Boolean operation. Jixin Tan and Jang-Sun Chen proposed methods for reconstructing three-dimensional models from singular edges and vertices based on the structure of half-edge data. Their methods are based on the generalized concept proposed by Guzik, but it does not take into account the more important problems that are associated with the data structure itself, namely the preservation of the connection between those deformed elements. The disadvantage of the basic mesh creation algorithm is that it is capable of replacing one defect with another. Instead of creating a singular edge, the resulting model will place a hole and island landfill. Such landfill can be evaluated as rubbish and removed along with isolated tops and hanging edges. In the end, further processing of such a model may lead to undefined result. Our approach is based on the idea of maintaining the connection between singular elements with the help of the so-called bridge. It allows us to connect one edge with all applicants. When two faces refer to one edge, they form a wall pair. In subsequent attempts to associate a new face with this edge, it will also be added to the container, which will already contain three elements. This will determine which elements refer to one edge and create a singular edge. Also, when we add the next face that refers to the same edge, it will create a pair with an odd element in the container. This approach allows to analyze of the model to determine all such edges using the simplest rounds if the bridge contains more than 2 elements. In this case, these items will not be removed in cleaning operation. I would like to demonstrate a comparison of the original approach and the part modified by us on the model of the part created in CAD system as SolidWorks that contains stiffeners. The model on the left is loaded with the basic half-edge implementation. In places of stiffener, embarrassment occurrent and depending on the sequence of triangles some were disconnected and removed during the model cleaning processing from rubbish. The second model represents our implementation, which preserves the connection between the elements. This model has not been destroyed and is subject to further analysis. Model number 2 is more trivial and contains an order of magnitude fewer faces. However, the specific of its creation leads to serious damage to the base implementation. About 1/8 of all faces were taken away. So, the proposed modify algorithm allows the connection between singular elements to be identified and to preserve the overall structure of the model. The advantage of the proposed algorithm is the simplicity and expansion of mesh recovery capabilities based on the algorithm discussed earlier. The result of proposed approach is the preservation of the connection in the topology during the formation of defects on polygonal meshes, which will make it possible to detect such and at the same time make it possible to carry out various kinds of manipulation. The disadvantages of this approach is the high memory cost for storing communication. Further research will be devoted to the improvement of the algorithm to ensure communication between all topological elements and its software implementation. So, thank you for attention and good luck.